So what I want to talk about here today is really about the open AI software ecosystem. And I want to see why that is important. And we are doing this open AI software ecosystem for AI everywhere. Now, what does AI everywhere mean? And it really means anything you can imagine, right? 'Cause AI everywhere today is no longer a controversial statement because we are getting, see AI getting applied to many different areas already. Now, since I got a chance to be here in person, before I came to London, I actually got a chance to go somewhere remote. And I'm sure all of you recognize that place? Yes? People nodding their heads here, right? Okay. So it's 11 hours drive from here. I did not drive from London. I drove from Edinburgh, which is still like 5-hour drive. It's beautiful country, very nice place. And now what I was doing hiking over there, I was wondering, what can AI do for me when I was hiking? And I was thinking, maybe I could get a virtual assistant, AI virtual assistant, that can tell me all the wonderful things around there. Some of these big rocks, what does that mean? All these big rocks and some of these small rocks, and all this little, not quite little, it's a blue water behind it. It was just beautiful there. Now, I was wondering whether there are monsters inside, but I guess went to the wrong lock. There's no monsters over there, right? So AI can be done for many different applications. Now, today, we already have seen AI in different industries, for different industries here. And my team and Intel overall, we've been working with a lot of customers, and we actually have seen applications all the way from healthcare to financial services to environment. So there are many AI applications already. Now, how do we get to AI everywhere? And you probably have seen, I talked about this a few years ago, other people talked about this a few years ago. AI is successful today due to 3 reasons. There's data, there's compute, and there's a algorithm change, right? The data is where a lot of you, enterprises, you have a lot of data today. And the compute is many of us, Intel and other companies, we're actually creating a lot of compute capabilities. And then we also have seen algorithm change as well. So let me just go over these things quickly. Let's say, what does that mean to have data? Now, this is a recent study from IDC that shows the data growth is exponential, right? That's another open secret, right? Data is going to be a lot. And we also have seen compute is increasing a lot as well. We have done not only the scalar computation, vector computation, matrices, and so on. So there's a lot of places we're adding compute capabilities for AI specifically. And then if you look at algorithm change, the models, some of these models getting huge, right? Trillions of parameters. And the kind of change we're seeing here is really also exponential, right? The big models are really big. And we are also looking at smaller models as well, because you may have small devices where you actually want to have smaller models to do the same thing, to do as well as all these huge models for these specific cases as well. So there's a lot of innovation on the model side as well. So what does that mean? Is everything cool, right? We're doing so well in all these three vectors. But when you look at it, many of our ideas just don't make it to the market, right? And I don't know how, whether my virtual assistant idea, my tour guide idea will make it, when that will make it to the market also, right? And simply because there are many real reasons we're not getting there. And when I was talking to a lot of customers, some of them actually invest quite a bit in AI, but quite a few of them just don't get any return from the AI investment. And there are many reasons for this. Some of these things we listed here. It's the lack of realized performance. And the AI does depend on performance. We need a lot of performance to do this. And we also, the infrastructure may not be quite mature, and the software may be too complex, not easy to use, or simply we just don't have enough software for this, right? So what do we do here? The key here really is software. As I mentioned, the three things we do, we're making very, very good progress. Data, compute, and algorithms. We're making good progress inside. And the solutions we're outside, we're not quite there yet. So there's a gap. The gap really is the software piece in between, right? So software is a bridge between the hardware infrastructure we're building to the solutions, to the millions of developers, to the billions of users we'll potentially will have down the road. So how do we do software here? So I'm the software person, as you probably can tell by now. And so there's a lot of opportunities here, and what Intel is doing is our strategy has three folds here. So what we want to do here is making software to have simplicity, performance, and productivity. Okay? There are three things we want to do here. And with these three things, we can make it easy for people to go from data to solution, right? Because at the end, all of you who have data, all you want is go from data to solutions. Right? You don't really care about anything else, right? And so how do we make it easy for all of you to apply AI so that we can get to AI everywhere? So how do we apply these three things to the software we're building here? Now, what makes it unique probably for Intel is we actually want to look at the entire software ecosystem. So I'm not here to tell you simply use this one particular tool, then everything will be cool, right? That's because the AI, if you think about AI is pretty broad, right? Pretty broad for many different reasons. And AI is pretty broad because sometimes you use the machine learning algorithms. Sometimes you use deep learning, right? You use different software for these. And if you think about AI, you start from data to deployment. So it's from data to training of model to deployment of model. So there's a pipeline. There's an end-to-end pipeline. So there are many pieces in between. And quite often people don't remember, AI is more than just model training. AI really is starting from data by itself. And the initial data processing actually has a lot of bottlenecks here today as well. So we have 4 quadrants. I have this here. So in the 4 quadrants, we were looking at machine learning, deep learning frameworks, and we're looking at the data analytics side of things, and we're looking at the AI domains. We want to make it easy, so we want to develop things so people, if you only care about computer vision, right? So you only look at some tool designed for computer vision. If you only care about recommendation systems, you only do that to that part. So we have domain-specific tools also, and we also have productivity tools to make it easy for people to get to solution, because quite often when you design these models, there are many parameters you need to tune for it, and it's a manual process. So when you actually try to get to how to design AI, there's a lot of work involved here, right? So over here, a lot of the things are actually not from Intel, right? You may recognize some of these things. So we actually work with many different partners. So partnership is very, very important for Intel. So what we want to do is we'll have an open ecosystem where everybody can contribute, and we work with many people, many companies to make it happen here. So over here, many software packages are from other companies, and some of these packages are from us, from Intel. So Intel actually develop our own tools as well. So our goal is to have a rich set of open software everybody can use here. Okay, so that's our overall goal here. So let me dig deeper into this. So first one to look at is performance. So we'll talk about 3 things here. So let me look at performance first. That's the foundation of what we do here. Now, at Intel, we actually have both hardware and software. Sometimes people are surprised. They think of Intel as a hardware company only. But in reality, we have a lot of software inside the company. Actually, if you think about the number of software engineers we have more than 13,000 software engineers. And that's probably bigger than majority of the software companies out there, right? It's pretty big for us here. And so our contribution is actually a combination of hardware and software. Now, on the hardware side, we actually have a very rich portfolio of hardware products, all the way from the CPU side to GPU side and to the special accelerators. And for all of these, we have special accelerations for it. And people may be surprised for things like CPU. CPU is very general purpose. You can do anything you want. But we have been adding special features for AI. And particularly in the next generation Xeon server, Intel's data center server, cloud server, we're putting a matrix computation unit called the AMX into it. And you can really think about the next generation CPU is like CPU plus GPU together. It has a same amount of capability as GPU and sort of embedded inside our CPU here. So there's a lot of capabilities that we're building here. Now, on top of this, we're also building GPU. We have discrete GPU, and we also have special purpose chips like the Habana chip, right? Now, because of a variety of things here, we want to make it easy for people to develop software on top of this. So that's why we initiated something called One API. So One API is the industry-wide standard. Standard API, everybody can contribute to it. And once you develop software on top of One API, your software can be movable. You can move from one platform to another platform. So you don't need to rewrite your code for different platforms if you write it against One API. So that's a goal, to make it easy for people to adopt a variety of hardware solutions here. And then on top of this, we enable all the popular frameworks and so on. So let's look at the hardware side first. So there's some performance data out of our next generation Xeon, which is what we call Sapphire Rapids. So this shows between the software optimizations and hardware capability like AMX, we can actually get 30x performance gain out of this. And the matrix unit alone can contribute to 4.8x performance gain. So it's very significant. It's really a jump when we look at the next generation CPU here. Now, so what does that mean? Sometimes people say, oh, between generations, we're getting faster. Are you really fast, right? And so we compare with the other alternatives. In this particular case, actually, we compare with GPU. So a GPU, which was designed for deep learning inference, can achieve something like 16,000 on the Resonate 50 side, 16,000 frames per second. And then on the Xeon CPU, we can actually get to 24,000. So on the server, CPU server, you can actually get better performance than a GPU dedicated for inference. So that's why I was saying, when you think about a Xeon processor, next generation Xeon processor, it's really a Xeon processor with GPU capability built in already. So it is a game changer. If you think about all you need to do is having a CPU, you can do everything here, right? Now, sometimes CPU alone is not sufficient. So then we're also working on GPU. So this is our flagship GPU called Ponte Vecchio. Is a code name inside. And what we're showing here is our GPU for training, for deep learning training, can be much faster than the alternative GPU in the market today. Now, what does that mean on the software side? So this is pretty new, and this is, as I mentioned earlier, what we do is we have One API libraries, something like One DNN, which is a One API library designed for deep learning performance here with all the primitives inside. And we've been adding optimizations into something like a TensorFlow. So after quite a few years of collaboration with Google, finally, actually a few weeks ago, in the latest release of TensorFlow, TensorFlow 2.9, Intel optimizations have become default. So what does that mean to be default? That means if you are using TensorFlow, all you need to do is go download TensorFlow. You got Intel optimizations for free on Intel CPU. So this is very meaningful because the TensorFlow is widely used. TensorFlow downloads is more than 100 million downloads a year. So it is very significant. A lot of production environment products are built on top of TensorFlow here. Now, the other thing we want to do here is simplicity. And for some companies, they may choose not to develop AI themselves. They want to say, hey, if I can find a solution somewhere, that may be the easiest way of getting the AI benefits without having to invest in developing for AI. And we want to make that happen also. And this is a new project. Again, it's a new thing here. This was announced last month in the Intel event called Intel Vision in Dallas. So our CEO announced this collaboration between Intel and Accenture. And the goal here is for us to get to develop on top of a lot of software and get to the reference kits. And the reference kits will make it easy for people to develop solutions. So you think about we're getting to solutions. We're providing solutions together with Accenture, providing solutions to customers. And now the 30-plus reference kits will be targeting different usage models. We'll be targeting different industries, for example, healthcare, for example, financial industry, and so on. So it will be very easy to adopt these solutions. Now, underneath this 30-plus reference kits will be a lot of these optimized Intel software inside. And on top of the Intel optimized software, we're also providing these templates, providing these models, and really, it's getting to be very, very easy for you to adopt when you try to get the solutions here. And our goal, again, is trying to reach. When I was working with the Accenture team a couple months ago, I said, my goal is to reach millions of developers, right? It's a scale we're looking for. And people ask, what's unique about Intel? Intel has a scale. We're everywhere. So we're looking for scale here. Now, this is just one example coming out of the Apollo project. It is for quality visual inspection. And in this project, we have bundled quite a few Intel optimized software inside, all the way from the Intel extension of PyTorch to OpenVINO to XGBoost, and quite a few things got there. Now, the results are very meaningful. You get pretty decent performance gain, right? 30%, 70%, and 300%. So I'm used to all these big numbers now. When I look at 70%, it's like a decent number. Used to be 10% is a huge number, right? So now we are seeing all these big numbers here. Now, the other thing which is very important is accuracy. Accuracy really is gold, right? When you design these AI solutions, you want to be accurate. And if you're seeing very significant 90% accuracy gain, that's a huge deal. So with a reference kit, people can change things and really improve the quality over there. Now Accenture is only one partners we have. We also have a Intel AI Builders program where we work with a lot of people, a lot of customers, and a lot of partners. And if you think about it, we have two different categories here. One is vertical partners, people targeting specific industry. We also have horizontal partners. You have seen that Accenture is part of the horizontal partners over here. And let me talk about the last vector here, which is productivity. If you choose to design and develop AI solutions yourself, you may want to use some of the tools to make it easy for you, right? So that's what we're trying to achieve here with the productivity here. And what I want to announce here today is actually a couple of things here. One is we are working on a variety of software here. And when we design these software packages to get large performance like 90x, 30x, you don't have to change your code a lot. It's just one line change of code, you can get to these performance benefits. For example, in your code today, you may use pandas. You may use pandas to do data pre-processing. And we have something called modem. Modem is completely compatible with pandas. And all you need to do is change one line of code to import. You get this 90x performance gain here. And the same thing, if you've been using scikit-learn, which is a widely used package, and the Intel has the Intel extension of scikit-learn. And again, it's a one-line change. You can get significant performance gain here. Now, so for something like TensorFlow, because we just became default, you don't have to change anything. So you just download the right version of TensorFlow, then you can get a performance gain here already. Now, this is even newer than the two new things I showed you earlier. The TensorFlow thing, TensorFlow default, and Apollo, these are the two new things. This one is actually we're announcing today between Hugging Face and Intel. So Hugging Face and Intel, we have been working very closely together, and we are creating together we're creating a new library called Optimum. So Hugging Face, you probably know, is the leader in natural language processing. And people just go there to download models from Hugging Face. And here, we're adding the hardware innovations and the software optimizations for hardware. All these innovations will be included in the Optimum library delivered through Hugging Face together with the transformer models. So that we're getting, going to be significant gain in a very easy, usable fashion. Now, in addition to Hugging Face, again, we also have a disruptors program where Intel works with many, many different partners as well. And Hugging Face is one of them. And we also have we want to stay at the cutting edge of AI change here. And we have other companies like Katana Graph from the graph analytics side, and as well as many others who are at the forefront of the AI change over here. So with that, I'll leave you with the last slide here. So what Intel is doing here is we're trying to shoot for scale, right? We're trying to go for AI everywhere. And the way we go for AI everywhere is we are going to be building an open AI software ecosystem. And that one, we think we can get AI to benefit everyone on Earth. And what Intel's mission, if you think about Intel's company mission, is we want to build world-changing technology to improve the life of every person on the planet. And this is very much consistent with the overall company mission here. So with that, a few seconds for questions. Oh, by the way, we have a booth here, not far away from here. So you check out some of the demos over there. And if you want more information, we have a link here, ai.intel.com. Any questions? Yes. Oh. Okay. Well, I'll step outside. Just feel free to look me up. We can talk outside. I think we're running out of time here. Okay. Thank you.